Hey calculus students, this is Dr. Callahan with week 6 Friday's lesson. I hope you guys had a good week and I hope you have an even better weekend. So go ahead and pause the video and get started with your warm-up. Okay, so last time when I saw you guys, we talked about the beginning of Unit 2, which is on derivatives, and we talked about instantaneous rate of change and slope and also the limit definition. So here's the first question that we talked about with your warm-up. And what I have here is I have f of x equals x squared minus x plus 1. And I need to go ahead and find the derivative of that, which the derivative of this is the unit function. So I have the limit as x approaches 0 for f of x plus delta x minus f of x all the way over delta x. Now somebody did mention that on the Math Excel, there was an alternative equation and it's still the limit definition formula, but they just use different letters. Because with f prime of x, I showed you that the same thing as m, which is slope, which is the same thing as y prime. So there's just different ways of writing this, which is also the same as dy over dx. So all of these symbols means exactly the same thing, which is just slope of 2 points. And with the delta x, as x approaches 0, it just means that the first point is getting closer and closer to the second point, or vice versa. And the two secant point, or the line, the secant line, is slowly getting closer and closer to the 1 point on the tangent line. So on Math Excel, they had another formula, which was a limit as a approaches h. So that will be f of a plus h minus f of a over h. And it is exactly the same concept. The only major difference is that on a graph, and let's say this is your graph, and you have 2 points. Your first point here, the x value is a. The x value here for the second point is a plus h because a is being shifted over, and this change of x value is h. So if I were to go ahead and label this, my x value here will be a, comma, y will be f of a. My second point, because the a is now shifting over horizontally, my x value will be a plus h, comma, and then my y value is f of a plus h. And if you apply that into the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, you will have and define that you will have your slope, which is the same thing as f prime of x, which is the same thing as y prime, is going to equal to f of a plus h minus f of a over x2 minus x1, a plus h minus a. And conveniently, your a cancels, so you're left with this formula. And this formula here that you see is the same thing as the limit formula here, which if you alternate the numbers and replace them a little bit is the same thing as this right here. So I just want you guys to get comfortable with it. So when you see this, you're like, what is this? It's exactly the same thing. All right, it says find the derivative function for f of x, x squared minus x plus 1. So let's go ahead and work on that. So first thing that I'm going to do is, using the limit formula, I am going to have f of x plus delta x, which is going to be x plus delta x squared, and we're going to have a bit of them, x plus delta x plus 1. I would have to go ahead and FOIL this, so that'll be x squared plus 2x delta x plus delta x squared minus x minus delta x, because you have to distribute the negative sign, plus 1. Your negative f of x is going to give you the opposite of this. So a negative x squared, a positive x, and a negative 1. And I lined them pretty nicely here, so you can just eliminate them directly. So that brings you a 2x delta x plus delta x squared minus delta x. And you can actually factor out a delta x here. So I have a 2x left plus a delta x minus 1 all the way over delta x. And this is your f prime of x with your limit as delta x approaches 0. So let's go ahead and apply the limit, because I am able to now, since I eliminated delta x in the denominator, I will not have an undefined. So this becomes 0, and then your f prime of x is equal to 2x minus 1. That is your part A. Okay, so for part B, it says find the equation of the tangent line. An equation is y equals mx plus b. You can also use point slope form, which is y minus y sub 1 equals m times x minus x sub 1. We actually reviewed this the first 2.5 weeks of the school year, because I know that we're going to eventually get there. So it's important that we review that. So hopefully you still remember this from Algebra 2 honors and then also Algebra 1. So this is your slope. To find the equation of a line, you will need y equals mx plus b. You will need to go ahead and figure out what m is and what b is. I know what m is. I have my slope right here, but I don't actually have a concrete number because I have an x value. But good for me, because, lucky for me, because they give me x equals -1. So then I'm going to apply that, which is a -2 minus 1, which is a -3. And that is my slope. So I'm going to apply that into this equation right here. So y equals -3x plus b. What else is given to me? Well, I know my x is going to be on -1, so I'm going to go ahead and replace that with a -1. Okay, still cannot find b. So what do I need to do? I need to figure out what y is. Most times they'll give you a point like -1 comma y, but in this case, it's really making work for it. So you know that f of x is x squared minus 1, or minus x plus 1. So I'm going to go ahead and use f of -1. So I'm going to switch back to the first equation here. So don't get confused with the f of x versus f prime of x, because that's easy to do. And you want to make sure you keep your work very clean and organized. So you have a -1 squared minus -1 plus 1. Do you remember when we talked about odd and even functions with a negative number that we practiced in the beginning of the school year? Well, ta-da, this is why we do it. So this is even. So I know my answer is going to be a +1, because -1 times a -1 is a +1. Double negative here gives me a +1, which is a 3. So that tells me my y value is a 3. So 3 equals -3 times a 3, or times a 1 is a +3, plus b, and my b equals 0. So then at this point, I am going to rewrite my equation. So that is going to give me hold on a second, let me make sure I'm doing this correctly. No, yeah, that is correct. Yeah, okay, so then my equation is y is equal to -3x plus 0, or just y equals -3x. Sorry, I had to second guess myself for a second, because I was looking at this and I'm like, I hope this is correct. And I checked it and it is correct. Now, if you decided to go ahead and, instead of using the slope-intercept form, you use point slope form, you will have the equation y minus 3 equals -3 with the parentheses x minus 1, or plus 1. There we go. My pen is lagging a little bit. And these are exactly the same. And you could check mentally, because you know -3 times 1 is a -3. When you switch it over, it becomes a 0. So your b is 0. -3 times x is a -3x. So if I were to go ahead and reduce this, it will give me a negative 3x. So check. Man, that was a long problem. All right. Okay, so with that said, today is just a continuation of the skill. I want you guys to go ahead and practice with a limit definition. The last one that we just went over was extremely difficult and somewhat complicated. I wouldn't say it was like extremely challenging, but it certainly is messy and yeah. So today, this is kind of our focus with the breakdown of today's lesson. We're going to continue with the slope of the tangent line, definition of the derivative. We're going to look at a video of introduction to limit definitions. In class, we're going to do a Kahoot. And if you guys are at home, go ahead and type in this link right here for the Quizlet flashcards, because Unit 2 has a ton of different vocabulary words. And this is the one that I use to go ahead and get you guys familiarized with them. So when you go ahead and type that in, this is the flashcards. There's 26 of them. So you just click on them, and at first you look at the definition, okay? And then you click on them and it gives you the vocabulary. And so you just go on to the next one. Next one, secant line. That gives you the definition of a secant line. This is the definition of something. And what is it? Wow, okay, it's that. All right, so then just keep going with us. Okay, so let's go ahead and take a look at our notes for today. So you want to go to week 6, Friday, and this should be your first page. These are some problems in your textbook that you guys can go ahead and practice with. This is going to be your video note. This is page 2. Here are some additional practice problems and my notes. Like for example, example 1, the examples are pretty much written out for you guys. Example 2 is right there. Some people, when they are introduced to the definition of a derivative, they just immediately understand it, like this formula right here. Other people, other students in the past, it takes them a few times to hear it over and over again to understand this fully. So what I did here is not only am I explaining this to you with my version that makes sense to me, but then I also have my notes written down here for you so you can read it yourself independently, take your time on it, and then really have a sink in reading this and looking at the diagram of the 2 points with the different lines. Here's example 3, example 4. And then these are some of the problems from the textbook with the steps that you guys can go ahead and practice. Try not to look at the steps initially, just look at the questions and then do it on your own independently before you look at the answer that is boxed right here. So there are several of them. And then if you need some additional practice, I also have these questions right here that you can go ahead and do. Okay, so now take a look at the video guided notes right here. Like I said, it takes a little bit for some students to have this concept sink in. So I explained it with my version. You guys had my notes with it. Now I have the guided notes of another teacher that also teaches calculus. So I have his video right here. Go ahead and type that in, and then you can kind of follow along with his guided notes and his video. And maybe he'll do a better job explaining it in a different variation that I have not used, that it's, a little bit easier to understand, or maybe the way that he explains it will be in a way that conceptually you can comprehend a little better than what I'm saying. And then when you're done watching that video, you can go ahead and practice with these 2 problems. Pause the video if you don't want to see the answer. If you do want to see the answer, here are the steps. All right, and that concludes our lesson today. So it's pretty sweet and simple for the most part. I am also starting a Zoom tutoring session over the weekends and also on Wednesdays after school. So I will be sending out a link. And when I usually do the Zoom meeting, it's usually kind of like a one-on-one thing. But if you have another friend who is also in calculus and you don't mind to have, that person with you on Zoom, I could totally tutor you guys at the same time on Zoom. And all the notes that I do on Zoom, I can just email it to you, so you can just simply pay attention. So I will be sending that link out on MS Team. And if that's something that you're interested in, it's just a Google form, and you just indicate which date and time you would like. And then I will go ahead and send you the link to Zoom. So be on the lookout for that. All right, you guys, I hope you have a wonderful weekend if I don't see you. And as always, stay safe and stay safe and healthy. And I'll see you guys next time. Take care.